Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 473 stable subarray with Leetcode boundary and interior sum. Hit the like button and subscribe button, join me on Discord. Let me know what you think about this one. I think prefix sum is a prerequisite for this problem. Sometimes I go over it, but this problem I just want to make that clear that that's a prerequisite. There are a lot of things that goes with prefix sum these days, so you should make sure to, like if there's something I don't really explain clearly, it's because you probably need to be a little bit, brush up on your prefix sum. Okay, but actually, before I bring up the drawing. So the key thing to note is that the length is at least 3. You have to find, some numbers and so forth, and yeah, I don't know. And the idea for me, because I like to not necessarily go over just like the correct algorithm, but my idea on approaching it, right? And I end up taking about 10 minutes for this one. I end up spending a long time for this one. I did, because of the bi-weekly contest, which I should have, I did draw a little bit of things. Not that helpful. I'll recreate it here in some way. But yeah. But the key idea you should be thinking about is just drawing it out. I guess that's the key thing. So okay, so I did immediately jump to prefix sum, and the reason is because you have this formula, right? That formula, actually maybe take it back just for a second. Because you have this formula where this is a sum, right? And then the other thing is, of course, n is 10 to the 5th. And because it's 10 to the 5th, you know that you cannot do n squared stuff, even a clever way. So you need to do a little bit faster. And typically, when you see those two things together, prefix sum at least has to come to the mind, at least for me. Because the reason why prefix sum works is because, and this is me drawing. The reason why prefix sum comes to mind is because, you have, let's just say you have an array here, right? This is an array, pretend they're rectangles. So you have, basically, because we're trying to do a subarray sum, which is another way of saying is that we're trying to find the sum of some segment, right? And the reason why prefix sum jumps right immediately is because if we do a prefix sum, then we can figure out this, and we can figure out this. Oops. Okay, pretend that they match up. If you figure out these two things, then you're able to get this, right? So the prefix sum idea I got immediately, but I wasn't able to kind of come up, it still took me 10 minutes to kind of figure out the next part, even though the actual implementation is very short. So initially I did think about a couple of ways of representing it, right? So I knew that, let's say, for example, this current number, let's say is x, that means that we're also trying to find another x. And also the sum inside is going to be x, right? So these are the things that we are looking for. And as a result, my initial idea would be that, we're just looking for a sum where, it's 3 times x, right? And I'm assuming that you know a little bit prefix sum idea here. And what I mean by that is just that we know, because here we know the current prefix sum, right? Which has this at the end. And the idea here is that for every increment of the previous prefix sum, we store them in a lookup table. And as a result, then we're able to identify this. For example, if this is t for total, then here we just look for t minus 3x. And just to also be clear, sorry, I have some allergy things going on. Also to be clear, because this problem can have negative solutions or negative array elements, right? And because of that, there could be actually multiple places in which to be t minus 3x, right? Because, because in that case, it obviously just means that these sums is equal to 0, right? Because of the negative numbers and so forth. Okay. So that was my first thought, and I was trying to think about, okay, that's fine, but there are a couple of issues with this, right? I don't know why I chose brown. It looks like poop. But in any case, I don't even know what I'm saying. Oh yeah, the reason why I was trying to think through this, but I couldn't figure out a way to do it because I was like, well, we know that the last number, this number is x, right? Because this is our current cursor, so we know it's x. That's fine, right? Then the question is, but you know, maybe you could even subtract by 2x or whatever, right? By not counting, something like that. But I wasn't really able to kind of come up with it because we have to, there are a couple of constraints, right? This is not the only constraint. We have to make sure that this constraint, this number is x, right? If it's not, then we don't count these. Versus the other, maybe another variation where we just use the prefix sum and we go, oh, this happens 3 times, that is Gucci, right? But no, you have to make sure that this is x. And then I was like, I don't know how to figure out if whether, you know, do an if check on all of these in a easy, good way, because there is a case in which you can build up everything to be n squared, right? For example, if like k is equal to 1 or something, and then, you know, and then all the numbers are 1, then you're going to have a bad time with this being n squared if you want to check all of them. So I thought about this for t minus 3x. I thought about this for like t minus 2x, and then maybe figuring a way to store it. And it actually took me a while. If you watch the live portion, you'll see it. And then the ultimate way that I did it is, and there are a couple of ways you can actually implement this. The way that I actually wrote this is by, change the color. The way that I actually wrote this is that I just, from here, right, this is 2x, right? So you could also have done it another way, by the way, but this is 2x. So I go, okay, well, if I have t minus 2x, then I can look up these buckets, right? But here, you know, we use a hash table to kind of look up what's the frequency of the times that we've seen this in the past. But we also want to just keep one more variable, an x. Because then now we know that here, and because it can only really, you know, there's only one item, so it only ties to one place. That means that this is only a solution if you're looking for the number x, because this number will never change, right? So that means that if you want to end an array here, you know, from here to here, then it has to be x. So that's the key thing that from a trivial prefix sum lookup count subarray problem is this introduction of an extra dimension x. And that's really the core idea. And once I thought about it, I mean, of course, in my mind, it took me a little bit more time to kind of convince myself. But the implementation was pretty straightforward, right? Yeah. So we have a lookup counter. And this is basically our lookup table for looking up the previous prefix sums and the last or in this case it'll be the first character, I mean, or number, right? So you have lookup, the count is our answer, right? Running count of the answer. Current is just a current prefix sum, right? That's it. And buffer, I missed the case that I didn't talk about. So okay, so one more thing that I would say is that I actually forgot about this, sorry. One more thing that I would say is that, okay, there is this one more condition, which is that the length has to be 3. Well, what does that mean? That means that another way of saying is that the length cannot be 1 or 2. Well, you can have 1. I mean, unless you, I mean, it's easy to check not to have 1, I suppose, unless you count itself for some reason, right? I mean, you can add it, but you can also just not track it relatively easily, right? And that's basically what you know. So I'm not gonna go over it. But then, okay, but what about n is equal to 2, right? Well, keeping in mind, I want to draw it, but I'm also don't want to draw it. Okay, so keeping in mind that, yeah, in this case, let's say you have x, you know, we have x plus x, where I'm trying to use the mouse, it's not great. Where you have 2 elements, right? So I don't know. There's so many ways to say it, but my point is that it's 0, right? So you could say that maybe if you have only two elements, then this is 0. So then you have only 2x, right? So yeah, because you have x, and then there's nothing in between. So this can only be 0, right? So as a result, then you can just check for it. So you could maybe check for that case. Another way to check for it is that, well, the timing in which we add the into the lookup table, right? So we look up we put in the lookup table by having an extra buffer, and this buffer means that if you kind of look back into this, all the buffer is saying is that because basically in a normal way, once you finish processing this, you just put it into the lookup table, right? But here instead, what we want to do is that after we finish processing this, we wait until the next thing before we put it into the lookup table. That's it. So that when you're on the next index, this has not happened yet. So it does not count this result. And as I said, this can only match this if x is 0. Otherwise, they can't really match anyway. The 3x the 3 times x conditional, right? Or technically 2 times x and then the x, and that's it. Yeah. As a result, we have this buffer to buffer as one element, and we keep track of the prefix sum. We count the number of things that we've seen before. I know that maybe I'm like a little bit weaker in explaining this part, but this builds on a lot of foundation on prefix sum, so definitely work on simpler prefix sum problems first. Yeah, I mean, I think if you understand that one, then maybe or those other ones, and it comes up all the time. There's like, I don't know, I want to say at least 5 different versions of it on Leetcode, so you'll come across them if you practice enough. Yeah, and then and then we just put things in the buffer, and then we return count, and that's it. Yeah. As you can see, this is all of 1, this is all of 1, this is all of 1. So this is in total all of n, and that is it. Yeah. That's all I have for this one. Let me know what you think. Thanks for watching, and you could watch me solve a live in contest now. Not that bad. Alright, integer capacity. This is n is big, no n square. Number of stable subarrays. Alright, let's see what stable means. At least 3, first and last. Okay, so it's a subarray problem, Larry, not a subsequence problem. First and last element of the array are each equal to the sum of the element. Okay. So that means that they have to be the same, and then the sum of the middle has to be, I mean, I guess it's just it. Well, I don't know if this is it, but we definitely need prefix sum. I mean, the way that we could do it could be n squared, so I have to be a little bit careful. Oh, I see. I see. Alright, because if the number is x, if the current number is x, then I mean, yeah, okay, this is maybe actually one of those drawing problems. So if the current number is x, that means that the prefix, the sum of the prefix I don't know, some t, I guess you don't really know. But that means that we want this is equal to x, and then this is equal to x, right? How does that work? That means that if we have x, we're trying to find t minus 2x. But it has to also be the case where I don't know that I get it. Well, I don't know if I get in n squared time, or a lot more than or faster than n squared time, right? I'm missing something. Because there could be multiple of these, right? How do you check all of them? So do you have to look at all the other previous trees? No. But okay, so code number is x. You want to, so there's actually another equation here, right? You want the other stuff such that okay, maybe I got wait, yeah, okay, so the type prefix is some t minus, so the current prefix is what does that mean? Okay, so this is 27 because it's this times 3, but if you have a 1 in before, then it's gonna be look for the 9. You look for 9 times 3. Okay. I mean, that part is easy, but I don't know how you would, because you have to still go through it, right? You don't, there's no greedy or anything. Am I confusing this? Okay, so there could be a lot of these, right? Am I missing something dumb? Because you can have negative numbers, that's the key part. If you cannot have negative numbers, then maybe that's a little bit easier. Actually, if you can't have negative numbers, it's trivial. But if we can have negative numbers, what does that mean? I think this part is also you have to do special cases with zeros. So do you search for t minus 2x? Oh, do you also hash? Because it has to be the n. Okay, I see. Because you also have to hash the number. Okay. Maybe. We'll see. Okay, maybe. I see. Maybe I should have thought of that. Because it is identical. I see. So something like this. I guess this is fine, maybe. I don't know. Because you can never have the entire... well, you can, but that's not what we're going to search for. We're searching for the first element, not the element including the first element. So, okay. Right, so then now we actually do look up... Do we even need to store this? Actually, maybe not. Maybe it doesn't even matter because we're just doing count, right? So then now we want. There's some weird thing with zeros. We might have to handle zeros different. I have to handle zeros differently. Or maybe just use like a queue of 2 items or something. All right, let's. I think actually this would catch it, but so let's just ignore it for now, and then we write count. It's going to return minus x times 2 x. Right. Okay. Let's see if that works without that one. Or like the first number should give. Huh? Oh. Yeah. Okay. Whatever. It doesn't matter. Shouldn't matter. 3 is wrong because there's only 1, so I think we'd overcount this. But 2 for this is good, so that means that we're listening. Maybe we could just right. So 3 numbers, right? This is so dumb. Nope. Something like that, maybe. 2011. All right, let's go. Am I confident? I'm trying to think a little bit before I submit. I think it's the right-ish idea. I probably should test more, but I don't know if there are any good tests. So those are both just ones, right? All right, whatever. YOLO submit. Okay. Whew, how am I doing on time? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later. Take care. Bye-bye.